Hi, we are Team 5 and we are doing the amazing water recycling shower. Just to give you a basic outline of what we're going to be talking about today, first we will start with an overview of the product. Next we will talk about basic design. After that, environmental impact, and lastly we will connect our topic in relation to the grand challenge of providing access to clean drinking water. Just an overview of the shower. So the shower recycles 70% of the water that it uses and also uses 40 to 70% less water than the average shower. Peter Brereton designed the shower while he was a student in the Royal College of Art in London. He was studying to be a design engineer and he designed the shower around 2004. He then sold the rights to the shower to the Australian technology company Syntep, which is producing the shower, and the shower should be available around 2013.
Okay, for basic design, it consists of 3 parts. On the top is a shower head. On the bottom is a reservoir to hold water and recycle water. And in the middle part, it's a system of filter and heaters.
Okay, next we're going to talk about how the shower works. The shower starts with 3.3 liters of water in the system already. This water passes through a mesh filter and is pumped to the hydrocyclone. The hydrocyclone removes heavier than water particles from the water and splits the flow so that 30% leaves to the underflow, carrying the majority of undissolved solids to the drains. The 70% of the water that is now clean exits through the top of the hydrocyclone. The clean water is then carried to the carbon filters where it becomes visibly clean and chlorine is removed. The water is now visually clear and enters a heat exchanger with an efficiency of 90%. The heat exchanger raises the temperature of the water in the inflow to the heater, reducing the energy input required to reach pasteurization and increasing the efficiency of the shower. The water then enters an electric heater where the temperature rises above 72 degrees Celsius or 162 degrees Fahrenheit for 15 seconds. This pasteurizes the water just like it does for milk and is sufficient to kill almost all biological pathogens. After leaving the heater, the water re-enters the heat exchanger where some of its heat is transferred to the water entering the heater, reducing the temperature of the water in the outflow, which reduces the amount of cold water required to reduce the outflow water temperature for use in the shower head. The presence of the heat exchanger therefore increases both the energy and water efficiency of the shower. The water then enters the mixer where it is mixed with cold water from the main supply to reduce its temperature to the requested temperature and to replace the volume lost in the hydrocyclone. After passing through the mixer, the water passes to the shower head for us to use.
Now I will be talking to you about the environmental impact. As the world's population increases exponentially, access to clean water will substantially decrease. By 2030, it is estimated that more than half of the world's population will live in areas of high water stress. Finding ways to reduce the amount of water we use every day is imperative to prevent extreme shortages in the future. The water recycling shower reduces individual water consumption by 70% from cleaning, filtering, and pasteurizing used water. This correlates to an upward of 10,000 gallons of water that each person can save every year. The process is very efficient because for every liter of water input into the shower system, the shower head outputs 3.3 liters of water. Another major benefit is that it uses 40% to 70% less power to operate. Because of the way the system works, it does not expend as much energy to heat the water as would a regular shower. This also means less carbon emission from the power usage.
Next is the connection to a grand challenge. One of the biggest problems we face today is providing access to clean water. But one way to fix this problem is reducing our wasteful water systems. This recycling water shower can save up to 40,000 gallons per household. This means that we are not only saving water by using less, but it has the potential to save local treatment plants up to 200 kilowatt hours in energy. This reduces the power consumption by these plants by up to 70%.
So, in conclusion, this water recycling shower will decrease environmental impact without sacrifices, and it uses significantly less energy and water. The good news is it will be available for sale in early 2013, and the shower will pay for itself in 3 to 4 years at current utility prices.
These are the sources we use. Again, thank you for listening. We are Team 5, and we hope you learned something intriguing about the water recycling shower.